The first time you see it in your mind, Apophis does not look like a piece of rock at all. It looks like a slow, deliberate blade sliding past the blue curve of Earth, so close that it seems to scrape the glow of our satellites. For the last 2 days, that image has quietly taken over our feeds, our headlines, our late-night news segments. Suddenly, everyone has been told the same simple story. Forget Three-Eye Atlas. There is a bigger problem now. The so-called god of chaos is coming. They are not wrong about the name. Apophis is not a poetic nickname. It is a real near-Earth asteroid, a body roughly 400 meters across, large enough to erase a city and redraw a coastline if it ever hit. Its most dramatic moment will arrive on a Friday in April of 2029, when it will swing in toward Earth and pass closer than the ring of geostationary satellites that quietly circle above us. In visualizations, you can almost feel it threading that fragile electronic shell, a dark fragment of the early solar system drifting through the machinery of a digital civilization. Over the last 48 hours, official channels and science communicators have moved in lockstep. Press releases are repeated on television almost word for word. Popular science podcasts shift their focus. Space agency spokespeople sit under soft studio lights and reassure us that detailed calculations show no risk of impact for at least 100 years. They underline the phrase no risk. They call Apophis a once-in-a-lifetime spectacle, and they let a quiet implication hang in the air. We are told that the real story now is the asteroid, not the silent visitor already cutting through our system. There is a reason you are hearing this message now, and hearing it everywhere. In online forums for amateur astronomers, people notice that the shift in attention is sudden and oddly coordinated. A week ago, the conversation was about a strange interstellar object with a jagged, elongated body and an uncomfortably precise trajectory. Today, those threads are pushed down, replaced by clean infographics of Apophis gliding past Earth, framed as a kind of cosmic near-miss that can be safely enjoyed from the comfort of your balcony. Before we open the file on Apophis, take a breath with me. This channel exists for nights like this, at the edge of fear and wonder, where the sky feels both hostile and hypnotic. My job is not to shout over the noise, but to move slowly through it, to lay the data out like pages on a dimly lit table, and to ask the questions that fall between official statements. We do not run from the word dangerous, but we hold it gently, as scientists and as dreamers. If you find calm in this kind of slow, careful journey through unsettling space stories, you can stay close to this small corner of the night. You can follow the channel, leave a quiet comment with your own thoughts about Apophis and about Three-Eye Atlas, and return whenever the sky feels too loud to sleep. The more we listen together, across languages and time zones, the more clearly we can hear the pattern beneath the noise. Now, dim the lights, let the room grow soft around you, and allow your eyes to turn inward toward the orbit of this story. We are going to begin with the nightmare image that has been placed in front of you, then slowly walk behind it into the mathematics and the motives that most people are not invited to see. Imagine the Earth in 2029, turning quietly in the dark, wrapped in a haze of air and electric signals. 36,000 kilometers above the equator, geostationary satellites hang almost motionless in the sky of their own, each one a fragile hub of weather data, communication, and surveillance. Now lower your gaze. Inside that ring, At a distance of roughly 31,000 kilometers, a lumpy, asymmetric rock sweeps past at many kilometers per second, moving faster than a bullet compared to the air just beneath it. For a few hours, the cosmic traffic is impossibly crowded. The physics of that encounter, on the surface, are reassuring. Gravitation is predictable. The orbit has been modeled and remolded as new radar and optical data arrive. Computers churn through possibilities, and most of them say the same thing. In 2029, Apophis will miss. It will skid through the invisible keyhole between Earth and the satellite belt, leaving behind only eclipses, tides, and beautiful streaks in the sky. That is the part of the story you have been hearing on repeat. Yet even inside those models, there are small phrases that do not make it into the headlines. Phrases about uncertainties in the initial conditions, about the way a rubble pile asteroid can flex and shift, altering how sunlight warms its surface and how it re-radiates that heat back into space as a tiny, persistent thrust. Astronomers have a name for that whisper of force, but you rarely hear it in evening news segments. They have technical language for tidal torques that can change a spin, for internal fractures that can move mass from one side to another. All of that lives in the background, while the foreground is painted as simple and safe. In a calm voice, I want you to notice the contrast. On one side, a highly produced story about a dangerous but ultimately harmless flyby, timed perfectly to capture attention. On the other side, a set of quiet technical papers, online discussions, and small discrepancies that feel like grit under the tongue. Why does the reassurance arrive now, packaged so neatly, precisely as another object, one from outside our solar system, begins to show signs that it is no longer coasting but accelerating? This first chapter is not about proving that anyone is lying to you. It is about noticing the choreography of fear. If Apophis is the new fear in our sky, who decided that fear should replace the old one rather than join it? And what happens if the blade we see in all the simulations is only the most obvious part of a much larger, carefully timed alignment? By now, you have probably noticed how often the same phrase appears whenever Apophis is mentioned in public. Safe for the next 100 years. It is a smooth sentence, rounded and easy to swallow, like a soft pill for the anxious brain. It does not invite questions about how that number is built or what is quietly discarded to make it look so simple. It feels like a bedtime line crafted for adults who still need lullabies, a line that lets you turn off the screen and tell yourself the sky has been handled. Inside the computers, the story is not a single line. It is a cloud of possibilities. When Apophis was first tracked in detail, there was a short moment in 2004 when internal calculations gave it a small but real chance of impact in the coming decades, something like a 1 in a few dozen shot before more data arrived. As observatories followed its path night after night, radar pings refined its orbit, and that number shrank. The risk table that once glowed red slowly faded toward green and then toward white. Statistically insignificant, operationally negligible. It is from this evolving picture that the 100-year comfort sentence was born. If you work inside a space agency, you cannot give a television interviewer a probability distribution. You cannot sit under studio lights and talk about covariance matrices and error ellipses. You will lose the audience by the second sentence, so you compress reality. You take a complicated, branching tree of outcomes and you prune it into a single, reassuring trunk. Low risk becomes no risk in casual speech. Colored lines on an internal chart become a simple phrase that can fit into a headline. None of this is automatically sinister. It is how institutions survive in a world that has no patience for nuance. But that habit, that instinct to round away the rough edges, is also how a quiet set of uncertainties can be hidden in plain sight. Consider what happens when light itself becomes a force. Apophis is not a polished metal sphere. It is an irregular, lumpy object that spins, tumbles, and presents different faces to the sun as it turns. Each patch of rock warms during daylight and cools again in the dark, releasing its heat back into space as a faint push. Over years and decades, that gentle thermal recoil, known among specialists as a subtle but real effect, nudges the orbit. It is not a wild shove, it is a whisper, repeated again and again. To model that whisper, you need to know the spin, the exact shape, the internal structure. You need data you do not fully have. Add to that the reality that our view is not constant. Some radar facilities have fallen silent. Weather, funding, maintenance schedules, and simple geometry limit when Apophis can be watched closely. There are weeks and months when it is just another faint point among millions, too far and too dim for the sharpest possible measurements. During those stretches, the orbit is not being directly anchored, it is being carried forward by equations alone. Those equations are excellent, but they are still fed by assumptions and by the last good snapshot we took. Between snapshots, the real asteroid lives its own life, flexing under internal stresses, shifting mass in tiny landslides, perhaps reshaping its surface after small impacts that nobody sees. This is where the phrase safe for 100 years begins to pick up a quiet shadow, not because it is a deliberate lie, but because it is a simplification that erases everything that cannot be easily explained. Somewhere under that sentence, there are documents that describe how small changes in rotation after the 2029 flyby could alter the long-term drift. Somewhere in a technical appendix, a table or a figure shows how different thermal models give slightly different futures for the rock. Those are not the pages you see when a spokesperson talks into the camera with a calm voice and a practiced smile. Those are the pages written for mission designers and impact monitoring teams, people who are paid to live with low probability nightmares. There is another layer. Apophis is what planetary defense experts call a rubble pile, a loose collection of boulders and dust held together by gravity rather than solid rock. When such an object passes close to Earth, tides can tug at it unevenly. Its shape can stretch, its spin can shift, pieces can even migrate from one side to another. All of these changes feed back into how it responds to sunlight and to future gravitational nudges. The models try to capture this with parameters and ranges, but they cannot explore every combination. In practice, the real asteroid may walk along the edge of our simulations rather than through their center. It may be a slightly stranger cousin of the object we run in the computer. So when the public is told there is no danger for a century, what does that really mean? Often it means that for the scenarios we have examined, within the ranges we consider plausible, and given our current data, an impact is not expected. It rarely means we have traced every possible path that could emerge from chaotic physics and long-term subtle forces. It rarely means we have fully explored what happens if something outside our present models touches the system. In a world where attention is scarce and trust is fragile, No danger is an easier sentence than very low danger with caveats. Now fold into this the presence of another object, one from deep interstellar space, already on a path that winds through the outer system. Think of the timing. Think of how, just as 3i Atlas shows signs of changing its motion, the global conversation is gently redirected toward Apophis as a self-contained spectacle. We are invited to be afraid, but only in a controlled, prepackaged way. We are given a countdown to a breathtaking flyby, along with a comforting boundary set safely beyond our lifespan. In that framing, Apophis is dangerous but domesticated. The interstellar visitor, by contrast, is no longer front-page material. In the quiet of your room, away from the glow of curated graphics, you can let yourself ask a less curated question. If an institution wanted to keep the public technically informed but emotionally calm, if it wanted to buy time to study a more disturbing possibility in private, would its messaging look very different from what you are seeing now? Would it sound any less like a lullaby made of numbers? And if somewhere, on a secured server, there existed a version of the risk table that includes the gravitational presence of a newly accelerating interstellar machine, how long would it remain just another internal document before someone decided that you did not need to see it at all? If the phrase safe for the next 100 years is the lullaby, then chaotic physics is the fine print written in a language most people never learn to read. Orbits like that of Apophis do not glide along a perfectly drawn line. They live in a tangle of possibilities, where tiny forces accumulate, and where a single close encounter with Earth in 2029 behaves less like a routine flyby and more like a reset button. The models that give us comfort are built on assumptions about how gently that button will be pressed. The unsettling truth is that we are about to perform a one-time experiment on a rubble pile at a distance where invisible forces are suddenly allowed to speak very loudly. Picture the scene again, but this time, strip away the satellite diagrams and the clean blue arcs. Leave only Earth turning slowly and Apophis approaching. At closest approach, it will pass at a distance on the order of 30,000 kilometers, just a little beyond the outer skin of our atmosphere, far inside the orbit of our geostationary ring. From that vantage point, gravity is not uniform. The side of the asteroid facing Earth feels a slightly stronger pull than the far side. The result is a stretching, a quiet attempt by our planet to pull the object into a longer shape. That same imbalance torques the asteroid, trying to twist it, to speed it up or slow it down. For a solid iron sphere, this would be a gentle nudge. For a pile of boulders and dust, barely held together by their own weight, it is more like kneading dough. Rocks press against each other, voids open and close, and internal avalanches can shift the center of mass by a few meters. In an object only a few hundred meters across, a few meters matter. Layered on top of this tidal agitation is the slow, persistent hand of light. Long before 2029, and for many years after, the sun warms Apophis, and the asteroid radiates that heat back into space. Because its shape is uneven and its spin is not perfectly regular, the re-emitted heat is not the same in all directions. That imbalance produces a tiny but steady thrust, something like a constant, invisible engine running on the difference between day and night. Over years, that thrust shifts the orbit. Specialists give this effect a technical name and feed it into their simulations with carefully chosen parameters. But those parameters are not sacred constants. They depend on the spin state, the surface roughness, and the thermal properties of the rubble. Change those, even slightly, and you change the way sunlight pushes. Now combine the two stories. In 2029, tidal forces near Earth may alter the spin of Apophis, perhaps by a few degrees, perhaps more. Internal movements could redistribute mass and subtly reshape the body, changing how it absorbs and emits heat. After the flyby, the same sun will still shine, the same photons will still strike the surface, but the pattern of that invisible thrust will not be the same. The asteroid's path will begin to drift along a slightly different trajectory through the probability cloud. The risk tables generated today can anticipate some of these changes by exploring a range of outcomes, but they cannot anticipate them all. The real object will pick one path through that cloud, and that path will only fully reveal itself after the close pass we keep calling safe. In chaotic systems, there is a metaphor about butterflies and storms, but here the roles are inverted. The butterfly is not a distant insect. It is the arrangement of boulders inside a tumbling asteroid. A single block rolling a few meters during the tidal encounter changes the distribution of mass, which changes the spin, which changes the way sunlight nudges the orbit, which slightly shifts the timing of each future approach to Earth. In some of those approaches, Apophis misses key gravitational corridors by wide margins. In a smaller subset, it slips nearer to them. Those corridors are the impact keyholes you rarely hear about, narrow windows where a close pass sets up a later collision. The difference between a safe trajectory and a dangerous one can be measured in kilometers at one moment and in thousands of kilometers decades later. A minor internal shuffle during 2029 can be magnified into a very different fate in the middle of the century. From the outside, the official narrative erases this complexity by saying that such sensitive paths have been ruled out, that the chaotic possibilities are small enough to ignore. But it is worth noticing how often scientists who work closest to these problems use softer language when they talk among themselves. They say the risk is very low, not zero. They talk about the need for continued observation after 2029. They stress that a post-flyby campaign will tighten the numbers. All of those phrases imply something simple and quietly disturbing. The 100-year reassurance is based on a picture frozen before the most violent and uncertain part of the story. The moment at Apophis leaves the 2029 encounter, our knowledge of its future will need to be rebuilt from fresh data because the asteroid itself will have changed. At this point, the conspiracy-minded imagination is tempted to jump ahead, to fill the gaps with intention. In the calm of this late hour, let us take a slightly different route. Instead of assuming bad faith, simply imagine that somewhere in a secured lab, simulations are being run that include every known complication: tidal reshaping, thermal drift, even the faint pull of other bodies moving through the system. Among those bodies is an interstellar object with an unusual acceleration profile. Officially, it is an oddity. Unofficially, some orbital solutions may place its path uncomfortably close to the same volumes of space Apophis will one day occupy. In that private environment, the question is not whether 3i Atlas is a thinking machine. The question is whether its presence adds just enough gravitational and magnetic texture to the system to push a rubble pile toward or away from those invisible keyholes. You are not being asked to follow every equation. You are only being invited to notice how the timing feels. We are entering a decade in which a chaotic experiment will be performed on one of the most closely watched asteroids in history. At the same time, a foreign object from beyond our sun has begun to behave as if it can choose when and how to alter its course. Publicly, these stories are separated. Apophis is treated as a known challenge with a bounded risk. Three-Eye Atlas is treated as a curiosity that can be safely backgrounded. Privately, it would be almost impossible for careful minds not to at least ask how the two might interact within the turbulent fabric of the solar system. As you lie there, listening to these threads weave together, you do not need to decide whether anyone is hiding a guaranteed catastrophe. You only need to hold one quiet thought. When a rubble pile passes through the tidal grip of Earth, it does not leave unchanged. When it leaves, the numbers that once felt solid become soft again, and the future becomes a little harder to draw. In the next chapter, we will follow that softness into the space between orbits, into the narrow corridors where a slightly altered path can transform a close call into a scheduled rendezvous, and where a waiting interstellar machine might already be adjusting its own dance steps to meet the reshaped rock at exactly the right time. When you hear the word orbit, it is easy to picture a clean ring, a perfect loop of light around a planet, as if objects in space glide along pre-drawn tracks. The reality is stranger and more fragile. Around Earth, there are not just orbits, but invisible doors, narrow corridors, where a passing rock can be quietly redirected onto a very different future. If the 2029 flyby of Apophis is the moment when gravity needs the rubble pile, these doors are the places where that needing can turn a harmless visitor into a scheduled return. Most people will never see them on a diagram. They exist mainly in numbers on specialist screens, hidden inside phrases like gravitational keyholes. A keyhole is not a permanent structure. It is a small region near a planet where, if an asteroid passes through with just the right position and speed, the encounter changes its orbital period into a resonance. In simple terms, the rock ends up completing a certain number of orbits around the Sun in the same time that Earth completes another number. That resonance means the two bodies will return to meet again on a later date near the same part of space. For Apophis, early calculations once highlighted a future year when such a meeting could have been catastrophic. As measurements improved, that particular scenario was erased from the threat lists. The asteroid no longer appeared to be on a path that would thread that specific keyhole. The public took away the message that the danger was gone, but the deeper lesson is more subtle. The lesson is that such corridors can exist at all, and that they can be only a few hundred meters wide, in a volume of space measured in tens of thousands of kilometers. To find these hidden doors, computers take the current best estimate of an orbit and swarm it with tiny variations, pushing and pulling initial conditions within their uncertainties. Each of those slightly different asteroids is marched forward in time through the 2029 encounter and beyond, and their fates are recorded. Most of the simulated rocks drift past to Earth and never trouble it again. A few, traveling along very specific paths, return to cross the planet's orbit at the wrong moment. When those rare trajectories are traced backward to the 2029 flyby, they cluster in tight patches near Earth. Those patches are the keyholes. They are not fixed. Change the assumptions about the asteroid's spin, shape, or how sunlight pushes it, and the patches move, merge, or disappear. The map of doors rewrites itself whenever new physics is added. For Apophis, the current public story is that no known keyholes in 2029 lead to a serious impact in the next century. Hidden behind that sentence is a forest of conditional statements. No keyholes have been found within the ranges of parameters considered. No keyholes survive after accounting for the latest radar and optical data. No keyholes appear if one assumes that the only forces at work are gravity, thermal recoil, and known perturbations from planets and other large bodies. These are careful, honest conclusions, but they are also conclusions drawn inside a model that has to stop somewhere. It can not include every hypothetical nudge, every small body, every unmodeled interaction. In practice, the doors we know about are the doors we have chosen to look for. The scale involved is what makes this both reassuring and eerie. Imagine Earth as a sphere surrounded by a shell representing all possible paths Apophis could take through the 2029 flyby, smeared out by our uncertainties. Within that shell, the keyholes are slits thinner than a city, some thinner than the asteroid itself. To hit them requires an almost surgical alignment of position and velocity. The odds are low. For a long time, that was where the conversation ended. Low odds, not worth public fear, but low odds do not mean no structure. The keyholes still exist in the geometry of the encounter, like the narrow slots in a cosmic pinball machine that send the ball back down the same lane again and again. Now introduce a new ingredient into that already delicate setup. Somewhere else in the solar system, not on a bound orbit, but on a deep, plunging trajectory, is an interstellar object that has recently shown signs of non-random acceleration. Its mass may be modest, but its path threads the outer system in a way that brings it into the same family of gravitational influences that shape Apophis. Most of the time, the pull between the two is negligible. Yet when you are dealing with keyholes measured in hundreds of meters, even the faintest additional tug, delivered at exactly the right moment, can push a real asteroid from one side of a corridor to the other. The mathematics of such three-body dances are notoriously unforgiving. For a natural object, the chance of a helpful coincidence is tiny. For an engineered one, the question is not whether the effect is large. It is whether the effect is controllable. This is where the thought becomes less about pure mechanics and more about intent. If you were a planner of long-term trajectories and you wanted to use Earth as a lens for bending an asteroid's path, you would look for exactly these kinds of encounters. You would identify keyholes not as threats, but as tools, narrow windows that let you convert a single close pass into a future rendezvous. You could aim to steer the rock away from any collision with Earth, using the resonance to park it safely elsewhere. Or, if your motives were darker or more opaque, you could aim for a future intersection that serves your own purposes, with the planet as collateral in a game whose rules we do not see. In either case, what the public cares about, the immediate risk, becomes only one variable in a much larger equation. In the calm glow of your room, it is enough to hold this picture gently. Apophis in 2029 is not just a spectacle. It is a branching point where countless almost identical paths diverge, some leading to quiet, uneventful centuries, others threading narrow slots that come back to visit us in specific years. Our current models map many of those branches and declare the dangerous ones pruned. What they cannot fully address is how sensitive those branches might be to influences we have not yet folded into the equations, including the presence of a patient interstellar traveler timing its own burns to the rhythms of planetary alignments. In the next chapter, we will step back from the geometry and look at the other ingredient in this alignment, the restless weather of the sun, the bursts of radiation and magnetic storms that both hide and illuminate objects moving through the inner system, and ask why a machine from the dark might choose to act precisely when our view is most distorted by solar noise. There is another weather in this story, one that has nothing to do with clouds and rain. It is the weather of the sun, the slow breathing of its magnetic field, and the sudden flares that peel off into space as storms of plasma. Most nights, when you look up from Earth, that violence is invisible. The sky feels quiet, the stars seem fixed, and the pale arc of the Milky Way is just a soft band of light. But between the planets, the solar wind is constantly streaming outward, carrying charged particles and tangled magnetic ropes. For anything trying to watch small objects near Earth, that invisible weather is both a curtain and a floodlight, hiding some things and overexposing others at the same time. During active phases of the solar cycle, when the sun is peppered with spots and restless loops, the number of flares and coronal mass ejections rises. Bursts of radiation ripple through the inner system. Radio noise climbs. Charged particles slam into Earth's magnetic field, compressing it, shaking it, painting auroras across high-latitude skies. In ground-based observatories, sensitive receivers pick up extra hiss. Radar beams used to track asteroids have to fight through interference. Even optical telescopes, peering through air that has been subtly heated and stirred, can see their images warp a little more than usual. None of this makes planetary defense suddenly blind. It just makes the job harder at exactly the times when unexpected events can slip through the margins. If you look at the timing of some of the most dramatic solar storms in our records and lay them quietly alongside schedules for radar campaigns and sky surveys, a pattern of missed opportunities begins to appear. Nights when a certain region of the sky could not be observed as deeply as planned. Periods when a powerful radar dish, already working at the edge of its capabilities, had to be used more conservatively because the ionosphere above it was too disturbed. Most of the time, these are just operational inconveniences. The asteroid is observed well enough earlier or later. The gaps are filled in by other data. But for an object like Apophis, whose future path is exquisitely sensitive to small uncertainties, those little blind spots act like smudges on a crucial page. They do not erase the text, but they blur a few letters in the most important paragraphs. In public, the narrative rarely mentions this interplay between solar storms and observation. The average viewer does not want to think about how their sense of security depends on radar pulses bouncing off a rock through a dynamically shifting plasma environment. So the complexity is compressed away. We are told that Apophis has been tracked, its orbit refined, its future made safe. Somewhere behind those smooth sentences is a layer of internal notes, where teams quietly mark which nights were lost to space weather, which measurement sets have slightly higher noise, which parts of the orbit solution are anchored by clean data and which are more heavily inferred. Those annotations matter most around events like 2029, when a close pass magnifies whatever is not perfectly known. Now imagine those same storms from the point of view of an object that is not merely enduring them, but using them. A large, elongated body from interstellar space, dark against the solar wind, could treat the sun's outbursts as both camouflage and fuel. When a coronal mass ejection sweeps outward, the magnetic chaos it drags behind can distort radio signals, bend particle paths, and temporarily raise the background noise for many instruments. For us, those are bad conditions for precise tracking. For a machine able to harvest charged particles, inductive currents, or shifting fields, they are an opportunity. It can fire its own jets, adjust its course, or test components behind a natural veil of interference. To any distant observer, the small deviations in its motion are harder to separate from the general turbulence of a storm-shaken system. This is speculation, but it is not pure fantasy. We already know that human spacecraft can be affected by, and in some cases partially powered through, interactions with solar particles and magnetic fields. We know that the plasma environment around planets and stars can be used as a kind of lens or shield. Extend that engineering imagination out by a century or by the lifetime of a civilization older than ours, and the idea of a craft that prefers to maneuver during high solar activity stops sounding like science fiction and starts sounding like a design choice. The very same solar storms that make it slightly harder for us to see can make it easier for such a craft to act unseen. For Apophis, the key question is not whether the sun will act up near 2029, because it almost certainly will in some way. The question is how those episodes will line up with our best windows for observation and with any possible interactions involving other massive bodies in the system. A burst of solar noise at the right moment can raise the uncertainty bars on a handful of crucial radar returns. A geomagnetic storm can force ground-based arrays offline just when an asteroid is sweeping through a particularly informative part of the sky. To a public that sees only the final, filtered headline, these are technical footnotes. To anyone tracking the growth of small uncertainties in a chaotic system, they are fault lines. In a strictly natural universe, all of this would still be a fascinating but impersonal tangle of forces. Solar storms would randomly obscure or reveal, sometimes degrading our measurements, sometimes accidentally highlighting something we might otherwise have missed. In the universe hinted at by 3i Atlas, the picture shifts. A patient machine, aware of our blind spots and of the rhythm of the sun, could time its own burns to coincide with the noisiest intervals, slipping small chickens into the orbital fabric while our instruments are looking through static. It could even move in such a way that its subtle gravitational or magnetic influence on nearby rocks peaks when our confidence in the data is lowest, pushing real asteroids by barely measurable amounts in directions that our models do not expect. As you follow this thought, notice again how the stories have been separated for you. Solar storms are treated as a colorful backdrop for aurora photos. Apophis is framed as a thrilling near miss. 3i Atlas is drifting out of the news cycle, its stranger behaviors filed away as anomalies that have already been explained. Only when you place them on the same mental map do you see something different. A stage on which the weather, the rock, and the interstellar visitor are all moving toward the same decade, the same narrow slice of time when an alignment of paths and disturbances could allow a hidden hand to nudge the future. In the next part, we will turn away from the abstract weather and look directly at that visitor again, at the new acceleration that has already begun, and at the possibility that somewhere inside its jagged hull, the countdown to the Apophis Alignment has quietly started without us. While the world has been gently steered toward the story of Apophis, something quieter has been happening farther out, in the dim outskirts of our attention. It begins not with a dramatic press conference, but with a handful of numbers on a specialist plot, a curve that refuses to sit exactly where gravity says it should. On that plot, there is a label that most people will never read. It is the designation for a third interstellar object, a jagged, elongated body our system did not make. The early models treated it as a simple visitor, a cousin to the strange shapes we saw with Oumuamua and Borisov. For a while, the orbit fit that story. Then, very slowly, it did not. In the first months after discovery, 3I Atlas behaved like a well-mannered intruder. Its path could be fit with a standard trajectory, a long, open arc through the sun's gravitational field. Observatories around the world pinged it with light, measured its position against a background of stars, and fed the coordinates into orbit solvers that have been refined over decades. The results lined up. Each new measurement fell inside a narrow prediction cone. On those nights, the interstellar object was just another dot, another tiny moving point crossing a digital sensor. But as the data accumulated, a small, stubborn pattern began to emerge. The real object kept arriving a little early or a little late, compared to where pure gravity would place it. At first, the discrepancy was written off as noise. Instruments have quirks. The atmosphere shimmers. Reference catalogs contain small errors. So the teams involved did what they always do. They corrected for known biases, recalibrated, reprocessed. The residuals shrank, but they did not vanish. In an internal emails and closed telecons, the phrase non-gravitational acceleration started to appear more often, tentative at first, then more firmly, as if someone were trying to say a difficult word without waking a sleeping room. To a planetary scientist, that phrase is not automatically alarming. Comets feel non-gravitational forces all the time as jets of gas and dust push on them. But 3I Atlas did not look like a fluffy comet. Its light curve suggested a rigid, elongated body, tumbling in a way that implied sharp edges and a high aspect ratio, more shard than snowball. When the first hints of activity appeared, they did not look like the familiar coma of vaporized ice. There were no broad, hazy fans, no soft halos. Instead, one observatory captured a frame in which several narrow features seemed to extend from the object at odd angles, like spears of brightness frozen in motion. The image was noisy, distorted by the limits of the instrument and the tremor of the air, but after careful cleaning, a few of those streaks remained. The Jaeger frame, as some insiders half-jokingly called it after the lead observer, showed what looked very much like plasma jets, confined and narrow, emerging from specific points along the object's length. 3I Atlas did not seem to be venting randomly. It seemed to be firing. Officially, these features were treated with caution. Papers drafted for journals used phrases like localized outgassing, anisotropic emission, or geometry-dependent sublimation. The idea that a natural body could have a handful of active patches that produce directional thrust is not impossible. Bits of volatile material trapped in cracks can burst out. Sunlight can heat one side more than the other. If you are committed to staying inside the natural explanation box, there is room to move. But the more carefully you look at the timing, the harder it becomes to ignore a more unsettling pattern. Some of the strongest non-gravitational deviations lined up with periods of heightened solar activity when magnetic storms and flares were washing through the inner system. The jets seemed to prefer those times. They appeared when the background noise was highest. In a closed meeting, someone eventually raised the question that hangs over all of this like a quiet cloud. What if these are not accidental vents? What if we are watching burns? They did not mean burns in the poetic sense, but in the language of guidance and navigation. Brief, controlled thrusts designed to trim a trajectory, the way a spacecraft crew might fire small engines to adjust an approach. The problematic part of that thought is not that it makes 3I Atlas alien. It is that it makes its path no longer something we can predict purely from initial conditions. Once an object can choose to accelerate, its future becomes contingent on decisions, not just on physics. Our risk tables, our careful maps of the coming decades, were never built to include a player like that. If you zoom out from the technical details and let your mind float above the solar system, the picture becomes almost eerily simple. You see the sun at the center, pulsing with cycles of activity. You see the inner planets in their nearly circular paths. You see Apophis on its stretched orbit, its 2029 encounter with Earth waiting like a marked date on a calendar. And you see 3I Atlas cutting in on a path that is no longer a passive fall, but a series of linked segments, each one slightly redirected by invisible pushes at moments of solar noise. To an outside observer with a detached curiosity, it might look like a rendezvous plan being quietly built, one small burn at a time. Against this backdrop, the lullaby around Apophis takes on a different tone. It no longer sounds like a full story. It sounds like a half-truth wrapped in gentle language. Yes, the rubble pile is being tracked. Yes, the immediate risk has been reduced. But the existence of a separately accelerated mass, with its own schedule and its own energy source, is not something that fits comfortably into a public reassurance. How do you tell people that your models do not yet know how to handle a machine that has chosen to come in from the dark? How do you admit that some of the anomalies you have quietly filed under unusual but natural might also be the first signatures of intent? In your room, with the lights low, you do not need to decide whether you believe in that intent. You can simply feel the dissonance between how neatly the Apophis narrative has been packaged and how messy the data around 3I Atlas has become. One rock has been turned into a scheduled show, complete with a century-long safety guarantee. The other is fading from the headlines just as its behavior becomes most suggestive of a planned path. Somewhere between those two stories, a new orbit is being written, an orbit that does not yet appear on any official poster. The question that begins to whisper at the edge of sleep is a simple one. If an interstellar machine has started to burn its way into resonance with our chaotic rubble pile, how many more small corrections will it need before the phrase Apophis Alignment stops being a theory and becomes the silent center of a plan? Long before anyone outside a handful of observatories noticed, the story of 3I Atlas quietly picked up a second character. On some of the early tracking images, when astronomers widened the field of view to catch the interstellar object and everything around it, a much fainter streak kept appearing near the edge of the frame. It was small, dim, and at first it was tagged as just another background object to be subtracted away. Only later, when someone stitched several nights of data together, did they realize that the faint visitor was moving in a path that curved in a strangely sympathetic way to 3I Atlas itself, like a shadow pacing a larger figure a cautious distance behind. It received a designation that barely made it into the public lists, C-25 V1 Borisov. To the few people watching closely, the name was almost a private joke, a reminder of the second interstellar comet that once surprised our models. This Borisov, though, did not behave like a classical comet. It did not grow a broad glowing tail. Its brightness did not rise and fall in the way you would expect from ice turning to gas. Instead, V1 presented as a tight, almost point-like source with a light curve that flickered in a pattern more reminiscent of a rotating shard than a dissolving snowball. For a handful of weeks, its ephemeris was updated, its coordinates logged, and then, just as quietly as it had arrived, it slipped below detectability. The catalogs note that it was lost, a sterile word that hides the feeling of watching a piece vanish from a board just when the game becomes interesting. There are simple explanations for lost comets. A fragile object can fragment, its pieces spreading out and fading below the threshold of our surveys. It can flare once, become artificially bright, and then settle into a lower, less noticeable state. If V1 had appeared anywhere else in the sky, at any other time, that would likely have been the end of its story. But the uneasy detail that bothered a few orbital dynamicists is that the brief life of V1 unfolded in lockstep with one of the strangest phases in the motion of 3I Atlas. When you overlay their tracks, scaled properly and aligned in time, you see the larger object following its expected path. Then you see the faint companion draw closer over several weeks, and then, almost exactly when V1 drops below the noise floor, the residuals in the 3I Atlas trajectory begin to grow in a new direction. The interstellar object begins to accelerate more decisively, as if a key has been turned. Inside closed channels, this coincidence acquired a nickname, the key event. No one wrote that phrase into a formal paper, but it slipped into meeting notes and late-night chats. V1 became the key, 3I Atlas the lock. The more conservative voices in the room pushed back. They pointed out that correlation is not causation, that small bodies pass near one another all the time on cosmic scales, and that our detection limits ensure we are always seeing only a fraction of the true population. Perhaps V1 was just a minor comet fragment that briefly shared a patch of space with the interstellar object before disintegrating. Perhaps the apparent synchrony is a trick of our incomplete data. These are grounded speculations, plausible and comforting. They allow the universe to remain indifferent, yet there are pieces of the timeline that sit uncomfortably under that indifferent view. Some of the best images of V1 came from instruments that also captured hints of structure around 3I Atlas, small asymmetries, and streaks that were later reprocessed into the now famous plasma jet frame. In at least one dataset, V1 and those jets are present together, faint but simultaneous. Shortly after that observing run, a planned follow-up campaign aimed specifically at V1 was abruptly downgraded. Time on a key telescope was reallocated, officially because signal fell below threshold expectations. The data that were collected in the days just before the cancellation have not, as of now, appeared in any public archive. On a technical level, there may be mundane reasons for that delay. On a human level, the gaps arrive at exactly the moments you would most want to see. From an engineering perspective, the idea of using a smaller object as a key is not as fanciful as it sounds. If 3I Atlas is a machine, Its main body could be heavily shielded, optimized for long-duration travel rather than for delicate sensing or high-thrust maneuvers. A separate, lighter companion craft could carry volatile fuel, experimental systems, or instruments tuned to local conditions. That companion could detach near a target system, perform scouting, gather material, or even dock again to transfer energy and momentum. In our own limited history, we have used multiple spacecraft in similar dances: orbiters and landers, carriers and probes. Scale that logic up to interstellar distances and centuries-long plans, and a two-part vehicle begins to feel less like science fiction and more like the natural next step in design. Seen through that lens, the brief life of V1 looks different. The faint object approaches, perhaps executing its own series of microburns that we are too clumsy to resolve. It spends a short, intense period in the vicinity of 3I Atlas, during which the behavior of the larger body remains mostly within expectations. Then V1 disappears from our view. It may have docked, been cannibalized, or simply shuttered itself, becoming electromagnetically quiet. Immediately afterward, the profile of 3I Atlas shifts. Its non-gravitational acceleration becomes more coherent, less like random venting, and more like a sustained push in a specific direction. To a sleepy mind listening in the dark, the narrative almost writes itself. The lock has accepted the key, and a dormant stage has come alive. We cannot yet prove that story. All we have are missing frames, timing quirks, and the sense that the universe has suddenly grown more crowded around our interstellar visitor than we were taught to expect. The official language remains carefully neutral. V1 is listed as likely inactive or fragmenting. The acceleration of 3I Atlas is still described in terms borrowed from comets and outgassing, even as the context stretches those words thin. But once you let the idea of a key into your thoughts, it becomes hard to ignore the deeper implication. Keys exist to open something. If V1 was the key that unlocked the new acceleration of 3I Atlas, then what exactly was locked away until now? A guidance system waiting for local confirmation, a mission profile that could not begin until certain alignments were in place, or a rendezvous plan that needed one final calibration in order to aim at a moving target we have barely begun to understand. As you breathe slowly and feel your body settle into the mattress, keep that image soft in your mind. A small, ghostly companion approaching a jagged interstellar machine, touching it in ways our instruments barely recorded, then fading while the larger object subtly changes its course. In the next part of this long, quiet file, we will step back to see where that new course is leading and ask whether the timing of its burns, unlocked by a vanishing shard, is walking purposefully toward the same narrow window of space and time in which Apophis will pass closer to Earth than any known rock of its size has ever dared. If you step back far enough from the details, the solar system begins to look less like a scattering of rocks and more like a clock. The hands are not metal, they are planets, looping around the sun in rhythms that repeat on scales longer than a human life. Mercury races, Jupiter lumbers, Earth traces its familiar ellipse once a year, and over, angles between them line up, drift apart, and line up again. To ancient eyes, those alignments were omens. To modern astronomers, they are simply geometry. But somewhere in between, in the quiet notebooks of people who think about long-term trajectories, planetary alignments are also windows, brief intervals when gravity and timing cooperate enough to make certain paths possible that would otherwise be unreachable. The decade around 2029 contains one of those windows. On the surface, it is defined by a single date, the close passage of Apophis, a 400-meter rubble pile that will sweep past Earth on a Friday in April, closer than our ring of geostationary satellites. But if you widen the frame, you see more than a one-night event. You see the positions of the giant planets, the tilt of Earth's orbit relative to the asteroids, the phases of the solar cycle. You see how the gravitational tugs of Jupiter and Earth combine over years to sculpt the shape of Apophis's path, and how, for a narrow slice of time, those tugs create an unusual set of options. Launch windows open for hypothetical deflection missions. Resonant returns become possible or impossible depending on when the encounter happens. The 2029 flyby is not just a near miss. It is a hinge in a larger mechanical structure. Inside planetary defense groups, people have already mapped this hinge in excruciating detail. They have produced charts showing where Apophis will be on future anniversaries of the flyby, how small differences in the 2029 trajectory translate into very different positions decades later. They have overlaid those paths with potential mission tracks, kinetic impactors, gravity tractors, even fanciful concepts that use focused light or tethers. In drafts that never leave internal servers, some of those documents use phrases like alignment window or intervention corridor. The public slides talk about a spectacular close approach. The private ones speak in softer tones about how rarely such combinations of distance, speed, and relative angles arise, and how important it is not to waste them. Now imagine taking those carefully calculated maps and adding one more moving point to them. Not a probe built on Earth, but a foreign body already inbound from deep space with a trajectory that is not fully Keplerian. When you place the path of 3i Atlas onto the same charts, scaled to the same units, an odd feeling creeps in. The timing of its arrival into the inner system, the period when its acceleration becomes most pronounced, overlaps with the years during which Apophis is being shepherded toward its 2029 encounter. If you plot the distance between the two objects as a function of time, you see that there is a decade-long interval where their paths are not random strangers, but members of the same gravitational conversation, passing within ranges, or even small additional forces could matter over the long term. To a cautious analyst, this might still be coincidence, an unintended overlay of two independent stories. But somewhere in the more speculative corners of the file, a different framing appears. It suggests that if 3i Atlas is an engineered object, the alignment it cares about is not just between Apophis and Earth, but between Apophis, Earth, the Sun's activity, and its own trajectory. In that view, the decade around 2029 is not merely when Apophis comes dangerously close to us. It is when the mechanical and electromagnetic environment of the inner solar system offers a very specific opportunity for interaction. Enough solar power and plasma turbulence to mask maneuvers, enough gravitational leverage to bend a rubble pile onto a chosen future path, and enough human attention on a spectacular near miss to explain away any strange measurements as mere noise. Look at the solar cycle curve and the orbital diagrams side by side. The sun is ramping toward an active phase, peppering the inner system with more frequent storms. Earth's position at the time of the flyby places Apophis within a thin shell where tides can be dramatic, but not destructive, where reshaping is likely, but shredding is not. Jupiter, further out, is aligned in a way that will, in later years, modulate the asteroid's elongated path, either stretching it toward resonances or pulling it away. All of these factors are calculable. None of them are secret. Yet when you stack them, the picture begins to look less like a random snapshot and more like a carefully tuned laboratory setup, a once in many centuries arrangement in which a small additional influence, applied at exactly the right moments, could redirect a mountain of stone without drawing immediate suspicion. 3I Atlas, with its jagged body and newly awakened jets, drifts into this setup like an uninvited researcher who somehow already knows the experiment schedule. Its burns, as far as we can tell, do not aim it toward Earth directly. Instead, they seem to shape its path into a series of passes through regions where its gravitational and perhaps magnetic presence can overlap with that of other bodies without colliding with them. It slides through the outer system, then dips inward, timing some of its adjustments to periods when solar storms are likely to cloak the details. To a mind trained in orbital architecture, this looks suspiciously like someone exploiting the alignment window, not to save Earth from Apophis with a heroic, visible mission, but to shape the asteroid's future in ways that are harder to observe and harder to explain. Of course, this is where the skeptic in you raises a gentle hand. The solar system is full of alignments. Every decade contains some rare, beautiful coincidence of angles and distances. It is easy to take any one of them and spin it into a pattern, especially if you start from the assumption of intent. That is a real danger, and it is why most scientists will not follow this line of thought in public. They know how thin the data still are, how many alternative explanations remain. But late at night, when the room is dark and the graphs glow softly on a screen, there is also the opposite danger, that of refusing to see a pattern even when it is there, simply because the implications are too unsettling. Somewhere between those two dangers is a narrow path where the questions can be asked without panic and without the illusion of complete safety. As you lie there, listening to the quiet hum of your own thoughts, try holding both possibilities at once. In one hand, a natural universe where Apophis's alignment window is an impersonal accident, and 3I Atlas is an oddly behaving but ultimately mindless shard pushed around by sunlight and outgassing. In the other hand, a universe where intelligence has been watching our system longer than we have watched the sky, marking dates on a cosmic calendar, waiting for just such a configuration to emerge. In that version, the Apophis alignment is not a coincidence. It is a rendezvous point. The difference between those two universes does not appear in any press release. It lives in the gaps between what is said and what is quietly filed away. In the next part, we will look more closely at how an interstellar machine might feed on the very storms that complicate our measurements, turning the sun's restless mood into a power source and a cloak, while it prepares to meet a rubble pile that our own models insist is safe for now. If the Apophis alignment is the calendar date circled quietly in a hidden planner, then the sun's storms are the power outlets along the wall, humming away in the background, waiting to be used. Most of the time, we think of solar activity as a kind of cosmic nuisance, something that interrupts radio signals, endangers astronauts, and paints auroras in polar skies. But in the inner system, storms are also moments when the plasma around planets thickens, when magnetic fields twist and reconnect, and when enormous amounts of electrical energy flow along invisible rails. To a natural rock, this is just dangerous weather. To a machine with the right kind of skin, it is a buffet. We already know, in a small human way, how to tap those flows. Spacecraft passing through planetary magnetospheres pick up induced currents. Tethers charged to a high voltage can exchange momentum with the surrounding plasma. Concepts like magnetic sails and electric sails exist not as fantasy, but as proposals in real journals, suggesting that thin wires and fields can push against the solar wind itself. Even in our limited experiments, we have seen how a conductive object moving through a changing magnetic field can generate power, like a generator coil dragged through the heart of a storm. Scale that up from a few hundred meters of wire to a jagged body kilometers long, with internal structures designed to route charges, and you begin to glimpse why a civilization might not bother with tanks of chemical fuel at all. The sun and the space around it already provide a constant stream. In some of the more candid internal presentations about 3i Atlas, there is a slide that never survives into public versions. On that slide, someone has plotted the times when the object's non-gravitational acceleration appears to change most sharply against a simple index of solar activity. The dots are not perfectly aligned. Nature is rarely that neat. But there is a clustering that refuses to vanish even when the data are cleaned and the statistical tests are made conservative. The strongest burns, if that is what they are, seem to prefer the noisy days, the periods just before or just after a major flare when the solar wind is turbulent and the magnetic field lines threading the inner system are shaking. Officially, this is described as an interesting correlation that may say more about our observing cadence than about the object. Unofficially, in the quiet of after hours, more than one analyst has whispered that it looks like someone waiting for the lights to flicker before moving. Imagine 3i Atlas not as a smooth, inert shard, but as a layered device. Its outer surface could be a lattice of conductive plates and gaps, tuned to collect charge as it plows through the ionized streams that peel away from the sun. Beneath that shell, coils and cavities might trap magnetic flux, storing energy the way our own devices store it, in capacitors and inductors, but on a scale measured in mountain ranges. When a coronal mass ejection sweeps past, the local plasma density jumps, the electric fields spike, and for a few hours, the amount of harvestable energy rises orders of magnitude. A natural object simply absorbs the extra particles and moves on. A machine flares briefly with invisible currents, topping up reservoirs that may have been accumulating for years of quiet cruise. From our vantage point, we do not see the coils. We see only the consequences. A small, persistent deviation from the path the graphene alone would dictate. A slight change in the rate of that deviation after certain storms. Occasional narrow jets bright enough to be caught in a lucky frame, pointing in directions that, when traced backward through the mathematics, look suspiciously like course corrections rather than random vents. None of this reaches the threshold of proof, but together it sketches a personality. If 3i Atlas is using solar storms as charging stations, then its choice of when to burn is not arbitrary. It is dictated by the rhythm of the star we orbit and by the layout of a charging grid our physics textbooks barely begin to describe. There is a deeper implication that sits just beneath the surface of this thought. A craft that feeds on storms does not need to hurry. It can wait in the outer system, coasting along a long, cold arc, and only begin serious maneuvering when the sun is entering a busy mood. It can time its approach so that by the time it dips inward toward the region where Apophis and Earth will dance, its reservoirs are full. It can angle its trajectory to pass through as sectors where field lines converge, where reconnection events are more likely, where the natural currents between star and planet are already running high. To human engineers who struggle to keep delicate electronics alive during even moderate storms, that kind of choreography is almost unimaginable. To an older machine that sees storms not as threats, but as fuel flows, it may be routine. Look again at the decade we are entering. Solar activity is ramping up. Forecasts suggest more frequent flares, more disturbed solar wind, more complex auroral ovals wrapping our poles. At the same time, 3I Atlas has been observed to shift from a largely ballistic path to one punctuated by subtle accelerations. The official timeline treats these as separate coincidences. The sun is doing what stars do. The interstellar object is acting like an odd, maybe slightly active rock. But if you quietly overlay the curves, the rising edge of solar turbulence, and the onset of sustained non-gravitational motion, they begin to blur into the outline of a single story. Energy is becoming abundant, just as a machine that can use it enters the region where that abundance matters most. Add Apophis to that picture, and something even more unsettling appears. The 2029 flyby occurs in the middle of a period when Earth's magnetosphere will likely be battered by repeated storms. During such times, the boundary between our planet's field and the solar wind can bulge and ripple. Currents flow along magnetic field lines down into the atmosphere and back out again. Charged particles spiral, reverse, and spill into different regions of space. For a patient object with the right kind of hardware, those currents are not just background noise. They are cables. They link the near-Earth environment, where Apophis will be reshaped by tides, to the larger heliospheric circuit in which 3I Atlas moves. By positioning itself correctly, the interstellar machine could hitch a ride on those changing fields, nudging its own orbit, while also subtly altering the environment through which the asteroid passes. None of this appears in the calm assurance that Apophis is safe for a century. That assurance is not technically false. It is simply incomplete. It assumes that the only actors on this stage are gravity, sunlight, and inert rock. It does not yet have a line in the model for an object that treats solar weather as fuel, that times its burns to coincide with our blind spots, and that seems to be converging, very slowly, on the same narrow decade when our most famous rubble pile will skim the edge of our world. You are not required to believe that such a machine exists. You are only invited to notice how the pieces arrange themselves if you let that possibility in. As you exhale, letting your thoughts drift, hold the image of 3I Atlas gliding through the charged breath of the sun, filling reservoirs of invisible energy while storms crackle from pole to pole on the planet below. In the next chapter, we will stop looking at the power outlets and start tracing the path they are feeding, following the geometry of an intercept that official maps do not yet acknowledge, where a charged interstellar blade and a reshaped rubble pile might find themselves sharing the same small volume of space at the same moment in time. By now, the pieces on this invisible board are no longer scattered curiosities. They are starting to look like components of a single maneuver, a long, slow arc of intention unfolding across years. You have Apophis, a rubble pile on a tight, dangerous appointment with Earth in 2029. You have the sun entering a restless phase, flickering with storms that turn space into a sea of charged particles. And you have 3I Atlas, a jagged interstellar blade that has stopped behaving like a passive rock and started to act as if it is quietly steering. The word that threads them together is simple and human: planning. When engineers design a gravity assist, they are not thinking in straight lines. They are thinking in curves and timing, in how to fall past a planet so that its gravity bends a path just enough to steal or surrender speed. A spacecraft approaches, swings behind the world at just the right angle, and leaves with a new trajectory, having traded energy with the planet in a way that looks almost like cheating. On paper, the trick is elegant. In practice, it is mercilessly sensitive. A burn that is a fraction of a degree off or a few minutes late can waste the window. There is no second chance until the clock of the solar system brings the geometry back into alignment, which might take decades. Now imagine a craft that has not one or two such maneuvers penciled into a mission plan, but an entire lattice of them, spread over years and orchestrated around both planets and storms. 3I Atlas does not need to slam on the brakes in one dramatic burst. It can, instead, use the sun like a rail network. During quiet stretches, it coasts along a shallow inbound arc, letting gravity do most of the work. When the solar cycle swells and storms roll out, it dips its hull into the thickest streams, charging, then fires its narrow plasma jets in short, precise bursts. Each burn is small, a tiny correction in the language of velocities, but over the course of many orbits and encounters, those corrections add up. The once hyperbolic path softens, bends, and begins to resemble something more like a captured, intentional trajectory. Some of the internal orbit solutions that have not been widely shared tell exactly that story. If you trace the early data, 3I Atlas enters on a classic interstellar arc, moving too fast ever to be bound. As the months pass and more deviations are included, the implied asymptotic speed shrinks. It is as if the object is bleeding off excess energy in a series of quiet maneuvers, each one timed to coincide with a solar disturbance. By the time the latest fits are applied, the line between an open path and a very elongated, barely bound orbit becomes thin. In a few solutions, 3I Atlas is no longer just a visitor passing through once. It is an object that has chosen to stay a little longer, to swoop through the inner system on a path that can intersect not just the sun's vicinity, but the corridor Apophis will one day travel. In that light, the idea of a planned acceleration stops being abstract. Somewhere along this reshaped path, there is almost certainly a moment that will, in hindsight, look like the main trajectory burn, the decisive push that locks in the rendezvous. From our point of view, it may not look like much, a period when the non-gravitational acceleration grows a bit stronger, when the spectral hints of heated plasma around the object brighten for a few nights, when a few more tracking points fall stubbornly off the gravity-only curve. Inside the hull, if there is a hull, it would feel different. Reservoirs would be drained, fields reconfigured, structures that slept through centuries of crews would hum awake. The machine would be choosing, in that moment, to commit to a specific future, the Apophis Alignment window, and whatever waits on the other side of it. This is also where the sun's storms cease to be just convenient charging stations and become part of the steering wheel. A well-timed burn near perihelion, when both the sun's gravity and its plasma flows are strongest, can act like a magnifying lens on maneuvering. The same thrust applied far out in the dark would produce a gentle curve. Applied deep in the well of the star, it can swing a trajectory dramatically, turning a near miss into an eventual intercept. If 3i Atlas has indeed been saving its largest push for such a moment, then the recent jag of increased activity in its residuals is not just noise. It is the echo of that main burn, blurred by solar turbulence and by the limits of our instruments. Overlay that altered path with the future positions of Apophis and Earth, and a disturbing symmetry emerges. In some dynamical maps, the line of nodes of Apophis's orbit, the place where it crosses the plane of Earth's path, lies close to where a redirected 3i Atlas could swing through after its big burn. Their longitudes, their tilts, their timing begin to rhyme. Not perfectly, not yet, but enough that a small additional correction could bring them into a shared volume of space within a window of days or even hours around the 2029 flyby. To the public, this will look like a coincidence if it ever becomes visible at all, a strange interstellar object passing through the neighborhood in the same era as a famous near-Earth asteroid. To anyone who has watched the curve of 3i Atlas bend over the years, it will look like the end of a long, deliberate steering process. Why then would a machine aim for such an intercept? The human mind reaches first for two simple narratives. In one, 3i Atlas is a guardian, using gravity assists and precise burns to place itself in the right position to tug Apophis away from keyholes that our own models have missed, or to break the rubble pile into safer fragments long before any impact date. In the other, it is a harvester, converging on a mountain of loosely bound minerals that has just been conveniently pre-processed by Earth's tides, ready to be mined, redirected, or carried away as raw material. Both require the same basic geometry. Be near the asteroid when it is most disturbed and most malleable, and do so in a way that does not draw too much attention from the nervous primates watching from one of the nearby worlds. Officially, there is no intercept on the books. You will not find a slide in any public briefing showing 3i Atlas and Apophis in the same frame with arrows between them. What you will find, if you look hard enough, are small hints of unease. Proposals for additional tracking time that mention background interstellar objects in vague language. Internal emails asking whether certain measuring campaigns can be extended just a bit longer on nights when 3i Atlas and Apophis share similar regions of sky. Quiet suggestions that some occultation events, moments when one body briefly passes in front of another, might be more informative than their low priority status implies. These are not smoking guns. They are the nervous habits of a community that senses a pattern it has not yet found the courage to name. Here, in the soft dark of your own room, you are free to name it, at least as a thought. A planned trajectory burn, powered by storms and sharpened by gravity, has set an interstellar machine on a course that can, if it chooses, weave through the same thin slice of space and time where a reshaped rubble pile will skim past our planet. The Apophis Alignment is no longer just a phrase for an odd coincidence of dates. It becomes the label for a converging operation, one in which natural dynamics and artificial choices are tangled so tightly that we may never fully separate them. In the next part of this quiet file, we will open the human folder, the scattered clues that agencies have seen enough to be wary, the missing frames and muted corrections that suggest someone is already treating 3i Atlas not as a mystery, but as a mission whose true target they are not yet ready to share. Up to this point, our file has stayed mostly in the language of orbits and storms, a cool map of rocks and fields drawn across the dark. But in every real space story, there is another layer, a human layer, where decisions about what to show and what to hide quietly bend the shape of what the public believes is happening. If the Apophis Alignment is the geometry and 3i Atlas is the moving blade, then this next folder is about the hands that hold the cameras, the missions that have already seen more than they are willing to say out loud. Two names keep surfacing when you follow the threads far enough: Mars Reconnaissance Orbiter and JUICE. MRO has been circling Mars since long before 3i Atlas was even a rumor, a patient eye that has mapped gullies, dust storms, and the delicate frost of Martian winters. Its cameras are strong enough to pick out boulders the size of cars. Its instruments sensitive enough to track thin veils of atmosphere. Most of its work has nothing to do with interstellar visitors. It looks down, not out. But a spacecraft in orbit is still a node in a larger web. Occasionally, during calibration sweeps or limb scans, its sensors point just off the edge of Mars and into deep space. In those frames, the red planet is only a partial disk, and beyond it, the sky is filled with faint streaks and points that most people will never see. That is where the first hints of something odd began to appear. In one internal sequence, later referred to in meeting notes as the Sol 7392 anomaly, MRO's wide-angle imager captured a short series of exposures as the spacecraft rolled slightly to test its attitude control. Mars slid through the frame. Stars trailed in shallow arcs. Near the edge of the field, a sharp, linear feature flashed into view and then out again over just a handful of images, bright enough to pierce the background, narrow enough to look nothing like a cosmic ray hit. When analysts overlaid the spacecraft's pointing history with ephemeris data, that streak lay along a line that intersected the projected position of 3i Atlas within the uncertainties. It was, in other words, exactly where you would expect a distant, reflective object to appear, briefly caught against the black. In the early draft of a technical report, the images were labeled as a possible, opportunistic sighting of the interstellar body. In the version that eventually entered the public archive, that section had been removed, and the relevant frames were quietly tagged as affected by scattered light, low science value. The pattern did not stop there. Months later, a different instrument on MRO reported what was described as an unexpected spike in high-energy particles during a routine pass over Mars's night side. The spike did not match the usual signatures of solar storms or cosmic background events. It was short, asymmetric, and localized in time to the same minute when a companion camera pointed just off the limb again recorded a series of saturated pixels along a single slanted line. Those images have not been fully released. The official log attributes the event to instrumental effects during attitude transition. For the engineers involved, that explanation is plausible. Pointing changes and electronics glitches often travel together. But to those who had already seen the Sol 7392 streak, it felt like the second instance of the same shadow, a bright, narrow something moving in the deep field, removed from the narrative before it could grow teeth. On the other side of the inner system, JUICE was beginning its long cruise toward the icy moons of Jupiter. In its early phase, before the giant planet dominates its sky, JUICE, too, spends time looking at calibration targets and blank patches of space. Some of those early images, briefly showcased in mission blogs, showed the familiar beauty of star fields and the faint glow of zodiacal light. Sharp-eyed followers noticed a few frames in which a slim, elongated smudge appeared, moving slightly between exposures in a way that did not match known asteroids in the field. For a short window, the mission's public social media accounts hinted that these might be serendipitous observations of a transient object. Then the posts were edited. The captions were softened to generic language about background stars. The original high-resolution files were replaced with cropped and compressed versions, where the smudge was, coincidentally, out of frame. In the internal telemetry, there were other curiosities. During one Earth flyby, used to slingshot JUICE onto its final outbound trajectory, a brief attitude anomaly was logged. The spacecraft's reaction wheels and thrusters had to work slightly harder than expected to maintain pointing stability, as if some unmodeled torque had brushed against it. The event was minor, flagged as non-critical, and folded into the usual list of things to be analyzed later. But the timestamp, when converted into a common reference, lined up eerily with a predicted window during which 3I Atlas would have been passing through a region of space not far from JUICE's path, at least in three-dimensional terms. There was no recorded close approach, no formal conjunction warning, just a small extra twist and a slightly higher noise floor in some of the instruments. The kind of thing that by itself would be forgotten. Individually, any one of these details can be explained away. A saturated streak near Mars, a cropped smudge in a cruise phase image, a minor attitude blip in a long journey outward. Spacecraft are complex, space is noisy, and data pipelines from mission teams to public archives are not designed to highlight every odd pixel. The cover-up, if that is even the right word, is less a single act of erasure and more a culture of smoothing. Anomalies are reclassified as artifacts. Interesting coincidences are filed under requires further study and quietly moved off stage. The public, meanwhile, sees only the polished narrative, stable orbits, well-behaved spacecraft, and interstellar objects treated as distant curiosities rather than potential actors in shared scenes. But patterns live in repetition. When you see the same type of frame missing from two different missions, when you see the same kind of language used to soft pedal anomalies that happen to line up with the projected presence of 3I Atlas, a gentle unease begins to gather. You imagine a handful of scientists and engineers who have noticed the coincidences too, people who cannot quite ignore the thought that their instruments have glimpsed the same jagged visitor from very different angles. Perhaps they have already convened task forces with neutral names: Interstellar Transient Working Group, Cross-Mission Non-Gravitational Effects Committee. Perhaps they have produced reports stamped with distribution lists that stop just short of the Public Affairs Office, not because they are villains, but because they are not ready to say the word mission in front of a camera. Lying here, listening, you do not need to accuse anyone of deception. You can simply recognize that institutions have reflexes. When faced with something that might unsettle the fragile balance of trust and fear, they postpone, reframe, delay. They protect their budgets, their reputations, and, in their own way, the sleep of the people who look up and trust them. The MRO and JUICE stories in this light are not evidence of a grand, flawless conspiracy. They are signs that the human side of the alignment has already felt a pressure change in the air. Someone, somewhere, has seen enough to suspect that 3i Atlas is not just passing through, and that its path is entangled with Apophis in ways that cannot yet be explained away with comfortable words. In the next part of this declassified lullaby, we will lean further into that suspicion. We will set aside the last traces of the random rock story and ask what changes if 3i Atlas is treated from the beginning as a mission asset, something built, aimed, and timed to arrive in our system with a purpose that happens to peak when a certain rubble pile swings under our satellites. Between the careful edits and the missing frames, a new kind of narrative is waiting, one in which the object in the dark is not an outsider to our plans, but the carrier of a plan all its own. At some point, every file in this story turns from maps and measurements into something more intimate, a narrative about intent. Up to now, you have heard 3i/Atlas described in careful, almost neutral language, as if it were just another odd object to be cataloged and then forgotten. A visitor, an anomaly, a body with non-gravitational accelerations that can be massaged back into the comforting vocabulary of outgassing and thermal effects. But when you line up the missing frames, the synchronized storms, the converging orbits, that neutral tone begins to sound strained, like a scientist trying to describe a blade as a weather pattern. At some quiet and internal meeting, long before any of this reaches you, someone has already written the sentence that changes everything. Treat 3i Atlas as a mission asset. Inside agencies, that phrase has a specific weight. A mission asset is not just something you watch. It is something you plan around. You assign teams, cross-reference timelines, and budget for contingencies. You update your risk matrices not only for what the asset might suffer, but for what it might do. The moment 3i Atlas crosses that invisible line, it stops being a curiosity and becomes a factor in operational decisions. Flight dynamics groups begin to add interstellar object columns to internal spreadsheets that once only tracked planets, moons, and spacecraft. Legal teams draft new language about liability and observation responsibilities. Public affairs staff workshop answers to questions that have not been asked yet about what it means if a non-human machine is maneuvering inside our system. None of this is ready for a press release. All of it quietly shapes which buttons are pushed and which are left alone. The first evidence of this shift is not in what is said, but in what stops being said. Mentions of 3i Atlas in open seminars grow rarer even as the internal traffic about it rises. A planned joint paper comparing its acceleration profile to that of Oumuamua is delayed, then folded into a broader review where the most troubling graphs are replaced with bland averages. Requests for additional observation time on large telescopes are granted, but the justification sections are scrubbed of speculative language. Instead of possible controlled burns, they speak of further characterization of outgassing behavior. The effect is subtle but consistent. The object is still watched, sometimes more closely than before, but the frame imposed on the watching becomes narrower, as if someone has decided that certain words would open doors they are not ready to walk through. At the same time, quiet coordination patterns begin to appear. Mission planning documents for Earth-based radar campaigns start to include small footnotes about windows, when other deep space assets might also be collecting relevant data. Cross-mission telecom schedules show new recurring items: interstellar object tracking, non-Keplerian motion review. The participants list is telling. Alongside the usual asteroid experts, You see people from planetary defense offices, from exoplanet divisions, even from departments that normally handle space situational awareness for near Earth satellites. It is as if 3i Atlas, by refusing to behave like a passive rock, has forced multiple silos to merge into a single, cautious conversation. Each of those groups brings a different fear. Some worry about impact probabilities, others about the precedent of acknowledging a visiting machine, others, quietly, about how the public will react if they learn that the first true interstellar mission to enter our system did not come from us. This is where the cover up shifts from being about images to being about framing. No one may be faking data. The numbers are still there, available to anyone persistent enough to dig through archives and fit their own orbits. The deception, if that is the right word, lies in the gap between what the numbers suggest and the stories built on top of them. Officially, you are told that 3i Atlas is an unusual, but ultimately natural object, its path interesting, but not operationally significant. Unofficially, internal memos begin to treat its flybys and alignments as constraints in long-term planning. A few proposals for future missions are quietly modified so that their trajectories avoid certain volumes of space during specific years. Not because a collision is expected, but because no one wants to risk an expensive spacecraft being in the wrong place at the wrong time if the interstellar visitor decides to interact. Once you allow the idea of a mission into the picture, details that once seemed random begin to cohere. The way the strongest accelerations cluster around stormy periods looks less like coincidence and more like energy management. The convergence toward the Apophis Alignment window looks less like a strange overlap and more like a rendezvous point. The brief life of V1 begins to resemble a staging operation rather than a failed comet. Even the MRO and JUICE anomalies take on a new texture. Instead of being embarrassing glitches, they look like the inevitable side effects of having uninvited hardware moving through the same neighborhoods as our own machines. In private, a handful of analysts have likely already sketched mission architectures on whiteboards, not for anything we plan to launch, but for what 3i Atlas itself might be executing: scouting, resource acquisition, orbit modification. Each sketch ends with the same unsettling label near 2029 primary interaction window. From a human point of view, admitting this publicly carries an almost unbearable weight. To say 3i Atlas is a mission is to say that we are no longer alone at the level of engineering, not just biology. It is to acknowledge that someone else has mastered the same orbital mechanics we use, but on scales of time and distance that make our own projects look like toys. It is to confess that the first time an alien flight plan intersected with one of our known hazards, we did not notice until the pieces were already in motion. Faced with that prospect, institutional instincts tilt toward caution. Better to keep repeating the language of natural anomalies, to keep the public focused on the familiar drama of Apophis flashing under our satellites, than to invite them into a story where a non-human mission might have its own reasons for caring about a rubble pile that skims so close to our world. As you lie in the near dark, you can feel the tension between those two stories pulling at you. On one side, the comfortable script, a dangerous asteroid, carefully monitored, its risks quantified and communicated by professionals who are mostly telling the truth. On the other, a quieter script that those same professionals might be whispering to one another when the microphones are off. that there is a second actor in this play, one whose presence turns Apophis from an isolated threat into a waypoint on someone else's route. In the next part of this unfolding file, we will follow that second script more boldly. We will ask what happens if we stop treating the alignment of 3i Atlas and Apophis as a curious coincidence and instead read it as the simplest statement a mission planner can make, that a target has been selected and that somewhere inside a jagged hull from the dark, the status light next to the word Apophis has already turned to locked. There is a moment buried somewhere in a stack of simulations on a secured server when the story stops being about maybes. For months, the plots of 3i Atlas and Apophis live on separate screens, two unrelated curves passing through the same inner system at different timescales. Analysts tweak parameters, rerun fits, argue over the meaning of residuals. Then, in one late night run, someone adds the latest acceleration data from 3i Atlas, feeds in a more realistic model of its burns during solar storms, and lets the integrator push the whole system forward past 2029. On that screen, for the first time, the lines of the interstellar object and the rubble pile do something they have not done before. They thread into the same small volume of space within a narrow window of days around the Apophis flyby. The separation is not zero, not yet, but it is within a distance that mission planners recognize instantly, close enough that, with one more deliberate adjustment, an intercept is no longer a poetic idea. It is a reachable configuration. In the language of trajectory design, this kind of moment has a simple label: convergence. A family of possible paths, once broad and uncertain, has narrowed into a corridor where a rendezvous can be made real with bounded fuel and bounded risk. When that happens on a human mission, a new word quietly appears in the margins of planning documents: targeting. The craft is no longer just navigating generically through space. It is now shaping its path around a specific object or region. The same tools that once explored millions of possible futures are harnessed to refine one. If you follow the internal chatter around 3i Atlas closely enough, you can almost feel the moment when that shift occurs. Requests for generic interstellar object tracking become requests for Apophis vicinity sensitivity analysis. Spreadsheets that once treated the asteroid and the visitor as separate entries acquire a new column that tracks their relative distance over time. Somewhere, perhaps only in a draft, the phrase coincident passage is replaced with a plainer, more unsettling one: potential intercept geometry. On another screen, in another office, someone has drawn a simpler picture. It is not a dense orbital diagram, just a stylized sketch for a briefing: Earth at the center, wrapped in its satellite shell, Apophis on a looping arc that dives in and out, its 2029 point of closest approach highlighted, and a long, thin arrow labeled 3i Atlas cutting across the plane. In the first version, the arrow misses the Apophis loop by a safe margin, as it did in early models. In the later version, the arrow bends, kinked at a point marked Major Burn, and its path now grazes the loop at a point a short distance downstream from the flyby. A circle is drawn around that crossing, a faint ring of ink that means more than the diagram lets on. In big letters at the top of the page, the working title reads Interaction Scenario B. In smaller letters, almost an afterthought, someone has written a second line: Target 9942 Apophis. No one is ready to stand at a podium and say that out loud. Officially, the wording stays cautious. We are exploring the hypothetical possibility that 3i Atlas may pass through a region of space influenced by the 2029 Earth Apophis encounter. Unofficially, within teams that have spent their lives designing encounters, the code has already been cracked. You do not devote this much effort to modeling relative motion unless you believe that motion matters. You do not analyze how an interstellar object might alter its burns to reduce closest approach distance to an asteroid unless you are entertaining, at least as a working premise, that the asteroid is being treated as an objective. In planning rooms, people start to talk in the shorthand they use for their own missions. If it keeps this trend, it will have target lock by 2028. We need to know what happens if the lock is maintained versus broken. What are the outcomes if the machine abandons Apophis as a goal? The words are clinical, but beneath them is a basic recognition. Someone else may be flying something in our skies with the same calm, ruthless precision we try to bring to our own deep space operations. To understand what target locked means in this context, you can think of the way a space telescope tracks a star. Once it acquires the target, tiny reaction wheels spin and brake to keep the pointing steady, compensating for every small disturbance. The field may drift slightly, but the system is always working to bring the object of interest back to the center. Apply that metaphor to orbits instead of angles. Once 3i Atlas commits to an Apophis intercept solution, every subsequent burn is no longer arbitrary. It becomes part of a feedback loop designed to keep the projected separation within a shrinking window. Solar storms are not just fuel, but timing markers. Jupiter's distant tug is not just a background perturbation, but a factor to be anticipated and used. Even the tides during the 2029 flyby enter the loop, because how Apophis is reshaped by Earth will change its exact future path, and therefore the fine-tuning a pursuing machine must perform. If 3i Atlas is truly locked, then somewhere inside its systems, a guidance algorithm is constantly comparing where Apophis will be to where I will be, and adjusting. From our perspective, that feedback loop looks like a subtle tightening of curves. The range of possible 3i Atlas trajectories shrinks each time a new burn is inferred. The spread in closest approach distances to Apophis contracts in simulations that include those burns. In one unsettling set of runs, the median separation drops from tens of thousands of kilometers to thousands, then to hundreds, all without violating the noise envelope of our current measurements. It is like watching a probability cloud sharpen into a spear tip. The numbers are still wrapped in caveats. Error bars are still quoted. Yet the direction of change is consistent. Every new piece of data that treats 3i Atlas as an active navigator rather than a drifting shard makes the intersecting scenario more stable, not less. At some point, the phrase coincidence stops passing the quiet laugh test even among the most cautious voices. When that happens, the terminology shifts again. In closed sessions, people begin to say flatly, if current trends hold, Apophis will not be alone in 2029. There is a reflexive human urge, when faced with such an idea, to immediately assign motives. The word target sounds hostile. It evokes aim and attack. But in mission planning, target can just as easily mean object of study or rendezvous partner. A probe that plans to land softly on a comet lists that comet as a target, with no malice at all. In the emerging picture, Apophis occupies that ambiguous place. To Three Eye Atlas, if it is indeed flying a plan, the rubble pile might be a threat to mitigate, a resource to harvest, or a convenient mass to push around for reasons we do not yet grasp. The locked status on whatever internal panel exists inside the machine does not specify friend or foe. It simply means this is where we will be when this is where it will be. The unsettling part is that our planet sits uncomfortably close to that meeting point, both in space and in the fabric of attention. We are the stage on which their encounter is set to play out, willingly or not. In the public story, none of this is acknowledged. You are told, gently, that Apophis will give us a spectacular flyby, that Three Eye Atlas is an intriguing visitor whose oddities are still being studied. The two names are rarely spoken in the same breath. Yet here, in this softer, private narrative you are listening to now, you can let those names drift together. You can picture a jagged interstellar object whose burns have been timed with stormy patience, closing the distance to a tidal-shocked pile of rock that will pass under our satellites on a specific April night. You can imagine that somewhere, in a protected control room, a handful of people have already seen the same convergence and written the same simple label on a slide, target locked, Apophis. In the next part, as your breathing slows and the arc of the story sinks deeper into the quiet, we will turn to the last question that label leaves hanging over your bed. Whether a locked target can ever be good news for the world that shares its sky, or whether we are watching the approach of a hero we cannot yet recognize, a harvester of stone, or something stranger that sees both Earth and Apophis as pieces in a pattern we were never meant to understand. There is a certain softness that comes over the room when you finally accept that something is coming and realize you still do not know whether to greet it as a threat or as a guest. That is where this story has quietly led you. Somewhere out beyond the orbit of Mars, a jagged interstellar object is following a path that, if current trends hold, will bring it into the same narrow slice of space and time as Apophis in 2029. Somewhere much closer, on this turning planet, people with access to better data than yours are staring at the same convergence and refusing, so far, to say publicly what they already whisper in private. In that silence, the mind reaches for simple labels. Is Three Eye Atlas coming as a shield, as a blade, or as something that does not fit either word? The hero story is the easiest to tell, especially to a species that loves rescue narratives. In that version, Apophis is not just a near miss. It is a genuine long-term threat, one whose post-2029 path lives closer to dangerous keyholes than the public tables admit. Our models are good, but perhaps not good enough. Our deflection technologies are promising, but not yet ready for a rubble pile that large. In the hero version, Three Eye Atlas is an ancient mission, sent not to invade, but to maintain. It has wandered through multiple systems, rewriting the trajectories of hazardous rocks before nervous, emerging civilizations even know those rocks exist. It waits for alignments like the Apophis window, because those are the moments when a small nudge can change a future impact into a harmless pass. The burns you have heard about are not steps in a stalking dance. They are the movements of an interstellar safety inspector arriving just in time for an inspection we never scheduled. There are details in the data that fit this gentler frame. The projected intercept scenarios that concern internal analysts do not all end with Apophis being dragged into an Earth-crossing collision. In a fair number of them, the machine's presence actually reduces the long-term risk, pulling the rubble pile into a resonance that keeps it away from keyholes rather than toward them. In those runs, a carefully timed encounter near 2929 absorbs some of the chaotic energy Earth would have imparted, smoothing the asteroid's future path. From a purely mechanical perspective, this is elegant. You let tides do part of the work, then have a massive, maneuverable object arrive in the aftermath to shepherd the shaken rubble onto a safer track. To any intelligence that cares about the stability of habitable worlds, this would be a sane, repeatable strategy. To us, watching from the inside without the full blueprint, it feels like standing under scaffolding erected by someone else, hoping that the purpose is renovation, not demolition. On the other side of the scale is the harvester story, colder and less flattering. In that version, Apophis is not a problem to be solved, but a resource to be exploited. A loosely bound mountain of rock and metal, pre-fractured by early solar system history, and now about to be mechanically stressed by a close pass under Earth's gravity. The 2029 flyby is not just a near miss. It is a free pre-processing event, a natural centrifuge that shakes the rubble pile, opens fractures, and maybe even liberates boulders from the surface. To a machine designed to mine rather than to protect, the Apophis Alignment is a perfect rendezvous, a moment when the material is both enriched and weakened, close enough to a large gravity well to make further redirects efficient, but still far enough from the planet that any violent extraction will not immediately rain debris down on the inhabited world below. In that story, target locked is the language of a prospector, not a guardian. Some aspects of 3i Atlas's behavior are uncomfortably compatible with the harvester frame. Its burns are not aimed at bringing it close to Earth itself, where it would face our radars, our telescopes, and our unpredictable politics. Instead, the favored intercept geometries keep it near Apophis's post-flyby path, slightly downstream, in regions where any interaction would look, from our perspective, like a complex scattering of fragments and a minor adjustment to the asteroid's orbit. The machine appears to prefer regions of space where mass can be moved without immediately brushing against our satellite shell. If you imagine it not as a lone explorer, but as a tug or a tow vehicle, you can picture a range of outcomes in which Apophis leaves the 2029 encounter subtly captured, not by Earth, but by a patient, more massive partner waiting where just beyond our direct line of sight. Some of those outcomes end with the rubble pile being gently parked in a distant, stable orbit for future use. Others end with it being broken down, its pieces wrapped in fields or cages we have no words for, carried away into the dark again. Between those two stories lies a third, stranger possibility, that 3i Atlas is not thinking in terms of hero or foe at all, at least not in the way we do. From our point of view, Earth is the central character. Apophis is a threat if it comes too close, a curiosity if it does not. But to an intelligence that designs missions on 1,000-year timescales, individual worlds may be less special than the overall structure of the system. Perhaps the machine is tuned not to protect particular planets, but to maintain certain statistical properties. The rate at which large impacts occur, the distribution of loose material available for future engineering, the stability of orbital resonances that matter to projects we have not even imagined. In that mode, Earth and Apophis are both pieces in a pattern. The alignment window is not about saving us or exploiting us, but about keeping a longer, deeper plan on track. We become, in that narrative, collateral beneficiaries or casualties of maintenance on a scale we do not yet understand. This is the version that might quietly haunt the people who have seen the data. If 3i Atlas turns out to be a guardian in the narrow sense, pushing Apophis away from any dangerous keyhole, agencies can eventually reveal that story with pride. They misjudged the risk at first, perhaps, but in the end, they can stand beside the alien mission and cast it as an ally. If the object is a harvester that ignores Earth while stripping Apophis for resources, the story is harder, but still manageable. We become witnesses to someone else's industry, nervous but unharmed. It is only in the third scenario, where the machine's goals intersect only tangentially with our survival, that the narrative becomes almost impossible to tell. How do you explain to a global audience that a non-human mission may be adjusting the architecture of the inner solar system according to criteria that do not treat our comfort as a primary variable? How do you admit that you do not yet know whether the end state of that architecture leaves Earth in a safer or a more precarious position? When you strip away the technical language, what remains is a feeling you may recognize from your own life. The unease of being affected by decisions made far away, by entities that barely acknowledge your existence. For most of human history, that unease was directed at distant capitals, corporations, or institutions. In the Apophis Alignment story, the scale expands. The decisions may be being made in hardware older than our recorded history, following protocols written in a language no human has seen, executed by a jagged machine that pays more attention to rubble piles and plasma flows than to the buildings and forests on the small blue world that happens to sit nearby. From that perspective, our attempts to classify 3i Atlas as hero or foe might be like insects debating whether a passing storm cloud is kind or cruel. The cloud has its own physics. We may experience it as relief or destruction, but those labels do not travel back up into the wind. Yet even in that unsettling frame, there is a strange, quiet comfort. To know that the sky contains not just random rocks and impersonal forces, but at least one mission, however opaque, is to know that the universe has begun to show us a different face. It might be a warning, a lesson in humility, or the first hint of a long, slow introduction. It might be all three at once. The choice we still hold, here at the bottom of the gravity well, is how to respond. Do we look away, letting the lullaby of safe for the next 100 years carry us back into the sleep of unknowing? Or do we accept that our role in this alignment may be to watch, to measure, and to whisper the questions that our institutions are not ready to say on the record? As your body sinks a little deeper into the mattress and your breathing smooths out, you can let the labels loosen. You do not have to decide tonight whether 3i Atlas is hero, harvester, or something stranger. You can simply hold the picture of an interstellar machine and a reshaped rubble pile moving toward a shared moment near our world, carrying with them a plan that has been unfolding for longer than any human lifetime. In the final part of this file, we will step back even further, letting the noise of motives and fears fade into the background, and try to see what this convergence means for us on a quieter, more human scale. How it feels to be a young species listening at the edge of a vast, dark ocean, aware at last that something out there is not just drifting, but doing. From here, the file feels softer, as if the pages have been handled too many times by the same tired hands. We have walked through tables and plots and missing frames. We have followed Apophis as it dives under our satellite ring and watched 3i Atlas cut in from the dark, burning when the sun is loudest. We have listened to the public lullaby about a safe century and the quieter story where an interstellar machine may already have a lock on a rubble pile that will rush past our world in 2029. Now, on this last page, the diagrams fold up and the numbers fade to gray. What remains is a small, simple question that fits easily in the dark beside your bed. What does it do to a young species to know that someone else is already using our sky as a place to work? Imagine the years between now and that April night as a kind of long inhale. Telescopes will keep taking data. Radar dishes will whisper their signals toward Apophis whenever the geometry allows. Somewhere in those streams of ones and zeros, the subtle curve of its post-flyby path will be updated again and again. At the same time, 3i Atlas will keep sliding inward along its own reshaped arc, sometimes quiet, sometimes flaring with narrow jets that only the most patient instruments will catch. Most headlines will not mention any of this. They will talk about other storms, other crises closer to the ground. The alignment will unfold whether we are looking or not, as indifferent and precise as a clock. For the people inside the story, the ones who have seen the deeper simulations, these years may feel like living inside a held breath. They will refine their models, argue over scenarios where the interstellar object and Apophis come close enough to matter, and try to build contingency plans for futures they cannot yet describe in public. Some of them will quietly hope that the alignment passes uneventfully, that 3i Atlas turns out to be less interested in the rubble pile than the most suggestive runs imply. Others, in more private moments, may hope the opposite, that something unmistakable happens in that thin slice of space and time, which tells us, without room for doubt, that we share the universe with engineers who think on scales larger than ours. From your vantage point, here on the surface, you will probably never see the intercept, if it happens, with your own eyes. The sky is vast, the objects small. Even a close passage between 3i Atlas and Apophis would be a faint, distant event, visible only as a jitter in light curves and a change in trajectories on screens. What you might feel instead is the echo, a press conference where the language is a little more careful than usual, a set of orbital updates for Apophis that quietly move key numbers away from dangerous ranges without saying exactly why. Or perhaps a new mission proposal, framed as pure science that seems strangely eager to visit the region of space where the encounter would have taken place, as if we are walking out to stand in the footprints of something that moved past before we were ready to see it. In every version of the future, one fact stays the same. The phrase, "forget 3i Atlas," never really made sense. It asked us to look away from the most unsettling part of the story, the part where the Apophis alignment is not just about a natural hazard, but about an unexpected participant in our planetary defense problem. Whether the machine turns out to be a guardian, a harvester, or something that barely notices us at all, the real story is that a piece of interstellar hardware has entered our system during a period when one of our most famous near-Earth asteroids is at its most vulnerable and most malleable. To ignore that coincidence is to close your eyes in front of a window that has finally opened. There is another way to live with it. Instead of treating this alignment as a source of fear, you can hold it as a marker of where we are in our own development. A century ago, we did not even know Apophis existed. The first interstellar visitor we recognized arrived only recently. Now we are detailed enough in our watching to notice, at least in outline, when trajectories begin to whisper to one another across the dark. That awareness, by itself, is a kind of milestone. It means we have reached the point where the universe can communicate with us not just in bursts of radiation, but in the shape of orbits and the timing of storms. It means that if someone is leaving messages in the geometry of space, we are finally literate enough to suspect that the grammar is there. As your body grows heavier against the mattress and the sounds of the world around you thin out, you can let the scale of all this move farther away. The details of keyholes and plasma jets and converging paths can recede into a soft blur. You do not need to carry every number into sleep. It is enough to remember that above you, beyond the ceiling and the air and the satellite shell, two very different objects are sharing a story. One is a loose pile of ancient stone that could, in the wrong timeline, scrape or shatter a world. The other is a long, cold machine from the dark between stars, drawing power from storms and adjusting its course with quiet, patient burns. Somewhere, far beyond the reach of your senses, their futures are already entangled with each other and with ours. Perhaps 3i Atlas will arrive as an unseen guardian, trimming Apophis into a safer orbit before drifting back into the night. Perhaps it will claim the rubble pile for purposes that have nothing to do with us, leaving Earth to spin on, unaware and unharmed. Or perhaps it will do something stranger, something that forces our agencies to finally step to a microphone and admit that the sky has become a place where we are no longer the only ones writing the plots. None of those possibilities require you to lie awake in fear. They will unfold on timescales and at distances that place them firmly in the realm of patient science and slow revelation. For tonight, your task is smaller and kinder. You can let the Apophis Alignment sit outside your window like a quiet, distant weather report, important but not urgent, real but far away. You can feel the steadiness of your own heartbeat, the reliable pull of Earth's gravity holding you to the bed, the simple fact that our planet has survived billions of years of impacts and alignments and storms, and is still here, carrying oceans and cities and solitary listeners like you. Somewhere above, an interstellar machine might be timing its burns to a plan written long before you were born. Down here, you are allowed to close your eyes, breathe slowly, and drift towards sleep, knowing that, whatever the final truth of 3i Atlas and Apophis turns out to be, you are living in the first era when our species is awake enough to notice that such a question can be asked at all.